Okay, so how we're going to begin chapter 6 is we're going to start with horizontal general equilibrium. So before we get into this, we need to know exactly what is general equilibrium. So this is a type of equilibrium. So when we say equilibrium here, we are referring to a steady state. So a steady state is where the economy is stable and there are no more changes that can happen to this economy. So it is a state of equilibrium where the whole economy, including the little markets within it, have got equilibrium itself. So that is when supply equals to demand and the prices in each market of goods and services are being determined. And again, when I say the whole economy, I'm talking about interacting markets. So here are interacting markets between consumers and producers themselves. So over here, I'm not only considering the market for one particular good, but I'm talking about many goods. So it could be good X and good Y. In general equilibrium, you cannot just look at one single good. You need to look at how the market for good X might affect the market for good Y. And when we talk about producers, you're also considering the market for labor. So that might actually affect the goods for goods market for X and Y itself. But for now, we're just going to leave out the market for labor so that we can simplify things. And there are two dimensions of general equilibrium. You have the horizontal general equilibrium, which we are talking about today, and of course you have your vertical general equilibrium, which we'll be talking about in another video. So let's talk about the formal definition of horizontal general equilibrium. So what this is trying to tell us is we're trying to analyze the relationship between equilibria across markets for final goods. So EQM here is actually equilibria. So equilibria here is simply the plural form of equilibriums. Okay, so you got many equilibriums. That gives you equilibria. Okay, just a fancy word for it. So final goods here, we're talking about the consumers. And horizontal general equilibrium is also known as intermarket equilibrium. So intermarket here, we're talking about the final goods, right? So obviously we're talking about the market for good X and maybe a market for good Y. Let's just keep it to two markets for two different goods so that things will be a little bit easier. So you see, good X and good Y, their markets might be interrelated because, well, maybe they are complements or they might be substitutes, right? So you know that the demand for good X would affect the demand for good Y if they are either complements or substitutes. Vertical general equilibrium, on the other hand, talks about the relationship between equilibria between producers and consumers. So we'll talk about this in another video. Today we'll be focusing on the horizontal general equilibrium instead. So before we look into that, let's talk about horizontal partial equilibrium. So obviously partial equilibrium would be a subset of general equilibrium, right? So let's look at the difference between partial and general. So in partial equilibrium, you are looking at the market for good X and good Y on a separate basis. Okay, you're looking at them individually and you don't care whether these two markets are actually interacting or not, whether they have an interdependency or not. So if you're going to look at a diagram over here, so this is the demand for X, okay, and this is the supply for X, which is affected by the wage rate. So we got equilibrium over here, which gives you the market price of Px naught. So that's market X, right? And then you go on to market Y. So this is the demand for Y and the supply of Y, and then you have an equilibrium price of Py naught, and that's market Y. So you're looking at these two markets separately. So the question here that you need to ask yourself is this: do they actually depend on each other? Alright, so that is what general equilibrium here is trying to ask you. So if there is this interdependency, how is market X and market Y connected? Well, do you find this graph familiar? Well, most of you hate this graph, so this is something that you will learn in chapter 2. So this over here, the indifference curve and the budget constraint, these two curves are the one that derives your demand for good X and your demand for good Y. And that is exactly how market X can be connected to market Y. It is through consumer theory. So with that said, the demand for good X might be affected by the price of Y, and the demand for good Y might be affected by the price of X. So you see, partial equilibrium over here is simply telling you that the price of a good can be determined for any given price of the other product. Okay, it does not care about what's happening in the other market, which is Not really good if you're looking at the economy at a larger perspective. Okay, so this is the part that you need to pay a lot of attention to. We're going to be talking about this interdependence on a horizontal manner using some mathematics and some graphs. Let's just say that we had a demand function for good x that looks like this. So the demand for good x, which is affected by the price of x and the price of y, is equals to a minus b times the price of x plus e times the price of y. Do not be intimidated by this bunch of algebra. So a, b, and e over here are simply parameters. So these parameters are fixed numbers. They can change, but they usually remain stable first. So these fixed numbers actually tell you the magnitude of change that happens to the demand for good x when the price of x or price of y changes. And price of x and price of y here are variables which are determined by the market. So look at negative b here. This is the law of demand. See, when the price of x increases, obviously the demand for x will decrease, and if you go the other way around, then the demand for x will go up. So that is the law of demand. Now for the parameter e, now this is slightly more interesting. When e is more than 0 or when it's positive, both goods are substitutes. Why? Well, it's quite simple. When the price of y increases, due to the law of demand, the demand for y would fall. And this would cause the demand for x to increase if they are substitutes. Right? So you can see there is a positive relationship between the price of y and the demand for x, and that is why e would be a positive figure. So what if parameter e was less than 0 or negative? Then x and y will be complements. Why? When the price of y increases due to the law of demand again, the demand for y would fall, and if they're complements, the demand for x would fall as well. As you can see here, there is a negative relationship between the price of y and the demand of x, and that is why when e is negative, x and y are complements. So mathematically, I've just shown you that there can be some form of interdependence between the market for good x and the market for good y. So what you will need next is a supply function for good x. So the supply for good x is actually affected by the price of x and the level of nominal wages. What you should notice is that there is going to be a positive relationship between the supply of x and the price of x, and this is simply due to the profit maximization rule of P equals to MC that you learned in chapter 4. You should recall now that a firm should produce at P equals to MC. So if initially the price of x was Px0 and it rose to Px1, what will happen is that the firm will start producing more now because you move up along the MC curve. And the wage rate would have a negative relationship with the supply of x also because of the marginal cost curve. So if initially we have an MC curve that is derived with the wage rate of W0, and let's say that the wage rate increases, so this causes the MC curve to actually shift up, and assuming that the price does not change, the firm will be producing lesser x given P equals to MC. So the supply of x written in the mathematical form could be C times the price of x minus D times the wage rate. So W here stands for the wages. Okay, now let's find the partial equilibrium for the market for good x. To find the equilibrium for the market of good x, you simply have to equate the demand for good x with the supply of good x. So you just take the two equations that you have seen above and you equate them together. So take note here that the parameter of e is a positive number. So what we're trying to say here is that x and y are substitutes. Okay, so that is the key assumption that we're making now. So what I'm going to do next is I'm going to rearrange this equation and I'm going to make the price of x the subject of this entire equation. And the reason for me to do this is I want to show you how the equilibrium price of good x can be affected by the price of y. Okay, so this formula here gives you the equilibrium price of x. As you can see, inside the right hand side, there is the price of y, which goes to show that the equilibrium price of x will be affected by the price of y. And now I'm going to show you in the graphical manner how the price of y can affect the equilibrium for the market of good x. So this is the demand curve for good x, which is affected by the price of y. and here is your supply curve for X, which is affected by the wage rate. So the partial equilibrium in the market for good X would be at point A, where the price of X is Px0 and the amount produced and consumed is X0. So let's say the price of Y increases to Py1. So the demand for good X will now increase. Why? Do you remember that we had this discussion over here? When E is positive, X and Y are substitutes, so that is our assumption here. So when the price of Y increases due to the law of demand, the demand for good Y would fall, and because X and Y are substitutes, the demand for X will increase. So increasing the demand for X would mean shifting the demand curve to the right. So this is dx1, which is reflected when the price of Y is at Py1. So let's assume that the price of X has not changed yet. If the price of X does not change, we would then be at point A prime on the demand curve. And the amount of X that the consumers are demanding would then increase from X0 to X0 prime. But take note of this, how much of X is the firm producing at the price of Px0? Well, you just have to simply look at the supply curve. The firms are still producing at point A, which is X0 amount of X. So as you can see here, demand does not equal to supply. And since the demand is larger than the supply, what we have here is an excess demand for X. And the excess demand for X is simply calculated as X0 prime minus X0. Alright, it's quite logical, right? If you've got more people demanding than what the firms can be producing, then you have an excess demand. And to find out what the excess is, you just simply take how much is demanded minus how much is supplied. So when there is an excess demand for X, what this simply means is that there is partial disequilibrium in the market for good X. So what we simply have to do is increase the price of X, right? So they can move up to point B, right? But wait, this increase in the price of X, which will cause an increase in the demand for X, as you can see over here in the new equilibrium, this increase in the demand for X would actually affect the market for good Y, because good X and good Y are substitutes, so you have to consider good Y as well. So how do you get horizontal general equilibrium then? And here's a quick recap. When we talk about horizontal general equilibrium, we are talking about equilibrium in all the markets, and we are talking about the market for good X and the market for good Y. And the answer here lies in excess demand. We are going to have horizontal general equilibrium when the excess demand for good X is equals to 0 and the excess for demand for good Y is also equals to 0. You see, when both of the excess demands are equals to 0, what this means is that both of the markets are in partial equilibrium. And when both of them are in partial equilibrium, then what it means is that you've got horizontal general equilibrium. So we now have to find a solution where we can have excess demand equals to 0 for both of these markets. And the answer to getting this equals to 0 excess demand lies in the price of X and the price of Y. How do they interact with one another such that you can get excess demand equals to 0 for both markets? So since we are talking about excess demand equals to 0, I want to introduce to you the excess demand curve. So on the left hand side, I have the space for the market of good X, and on the right hand side, what I'm drawing here is, you'll notice on the horizontal axis is the amount of excess demand for good X, okay, and the vertical axis is the price of X, similar to the graph on the left side. And right smack in the middle here, this is where the excess of demand is equals to 0. So this is what we want to achieve. We want to find the price of X that can give you this EDX equals to 0. So here's the demand curve for good X, and here is the supply for good X. So let's assume that initially we had partial market equilibrium for the market of good X, right? So initially the price of X would be Px0, giving you an equilibrium of point A. And in the right graph, what you will have is that you will be at point A as well. And the excess of demand for X here will be 0 because demand equals to supply. Alright, let's assume that for some apparent reason, the price of X is going to increase from Px0 to Px1. So this increase in price is not caused by the market dynamics, but it's just some random increase in the price. So now, the demand for X is going to be here, D1. And the supply of X is going to be here at S1. So now we need to plot out the excess demand curve for good X. So the excess demand for good X here is simply D1 minus S1, right? But the thing is that D1 is lesser than S1. This makes the excess demand for good X negative, okay? It's also known as the excess supply, okay? But because we want to find excess demand, we will say that the excess demand here is negative. And since it's negative, we're going to plot it somewhere here, just on the left side of the vertical axis. So there's excess demand 1. Okay, now let's assume that the price of X is going to fall randomly from Px0 to Px2. Okay, so let's draw that horizontal line across again. So at the price of Px2, where is the demand for good X? It is over here. So this is D2. And the supply here would be S2. So to find the excess demand for X, you just have to take D2 minus S2, right? So now that the demand is more than the supply, you would have a positive excess of demand for X, right? So EDX2 would be somewhere there, like I plotted in the diagram on the right. So we just connect the dots, and what you would have is the excess demand for X curve. See? Quite easy, right? Alright, now let's bring in good Y. Let's assume that the price of Y is going to increase to PY1. So we've just established previously that when the price of Y increases, the demand for X is going to increase, causing this demand curve to shift out. So we need to be over here. This is partial equilibrium for the market for good X, and that is also where the excess of demand for good X is equals to 0, given that the price of Y is PY1. So to be at that point, the price of X would have to be over here, and that gives you an excess demand for X equals to 0, right? So if the excess of demand of X is equals to 0, then the excess demand for X curve would have to simply strike through that point, and what you will notice is that when the price of Y increases, the excess demand for X curve would shift to the right. Okay, so what this means is that for the excess of demand for good X to be equals to 0, the price of X must increase when the price of Y increases. As you can see, there is a positive relationship here between the price of X and the price of Y, just like how we established in the mathematical illustration earlier. So I'm going to draw a graph to show you this positive relationship between the price of X and the price of Y. So if it's a positive relationship, what you should see is a upward sloping curve that is called the excess demand for X equals to 0 curve. Okay, so this EDX equals to 0 curve actually shows you the relationship between the price of X and the price of Y. Now take note that the EDX equals to 0 curve is different from the EDX curve. The difference here is the equals to 0. Okay, so that is the key thing. And one of the obvious questions that you might be asking yourself right now is, why does he start here? You know, why does he begin somewhere in the middle of the horizontal axis? Well, I will need to actually use the mathematics to show you how I came out to this conclusion. So let's go back to the basics. How do you find the excess of demand for X? Well, you simply take the demand for X and you minus the supply of X, and you want this to be equal to 0 because you're looking for EDX equals to 0. So you write down the equations that we have established previously, okay, and you equate that whole thing to be equals to 0. And what you want to do now is to form a linear equation so that you can see what the EDX equals to 0 curve looks like in a graph space of PX versus PY. So take a look at the vertical axis here. The variable here is Py, right? So what you want to do is to form something like y equals to mx plus c. So what I'm going to do now is I'm going to isolate the price of y on the left hand side of the equation. Okay, so I'm just going to go through this very quickly because what we want is the y equals to mx plus c format of this equation over here. Okay, so this is what we have. As you can see, it is in the form of y equals to mx plus c. So check this out. B plus C divided by E gives you a positive gradient. So that is why the EDX equals to 0 curve is upward sloping. And what you will notice is that the vertical intercept is a negative figure. And that is exactly why I started the EDX equals to 0 curve over there, because it has a negative vertical intercept. Okay, so that is my explanation for it. I think you will find this pretty straightforward. Okay, so what's interesting is that all these things within this green box over here, these are the factors that shift the EDX equals to 0 curve. Okay, parameter A, D, E, as well as your wage rate. So when the wage rate increases, what this means is that the vertical intercept simply becomes more negative. So what happens is that the entire EDX equals to 0 curve is going to shift down. Okay, let me just show you that. So the red EDX equals to 0 curve is a new one because it's got a more negative vertical intercept. So the intuition behind why the EDX equals to 0 curve will shift down is because take a look at the market for good X. When the wage rate increases, what happens is that the supply curve is going to shift up, right? And you see, you're going to need to have a higher price of X to achieve the partial market equilibrium, and that is why the excess demand curve is going to excess demand for 0 curve is going to move towards the right. It is simply because you need a higher price of X to achieve partial market equilibrium. So obviously now you will be thinking, okay, so we've got EDX equals to 0. How the hell do we find EDY equals to 0? Because we need EDY equals to 0 so that we can intersect that with EDX equals to 0, and then we can get the level of PX and PY that gives us general equilibrium. Oh, finally. So do we have to do all the same mathematical and graphical crap for good Y? No, you don't have to, don't worry, right? You just have to remember that this assumption still stands. X and Y are substitutes. So if we had a demand function for good Y, that is of course affected by the price of Y and the price of X, that looks like this. Okay, what you will notice here is that plus M, okay, actually shows that X and Y are substitutes. Okay, so M has to be a positive figure. Now, a supply function for good Y would be very simple. It would be something like this. So this is actually the same for good X, it's just that the parameters are different. So again, we find the excess demand for good Y. We take dy minus sy equals to 0. And we now make the price of Y the subject of this entire equation again, so that we can fit it into the graph that you see on the right hand side. Okay? So here's my linear equation. Take note that all the things in front of Px, these are positive numbers, and that is why you will have a positive slope for the EDY equals to 0 curve, and you will have a positive vertical intercept for the EDY equals to 0 curve. So positive vertical intercept and upward sloping, there you have it, your EDY equals to 0 curve. You see, it is that easy. The only reason why we went the long-winded way for the excess demand for good X equals to 0 curve is because you had to understand what that stupid curve means. And finally, this point over here is known as the general equilibrium point. Okay, so this point simply tells me that when the price of X, okay, when the price of X is equals to Px star and the price of Y is equals to Py star, we have general equilibrium. Okay, which means that we got partial equilibrium in the market for X and the market for Y. So the market forces will always push the price of X and the price of Y towards this general equilibrium point. Now, I would like to take note of JW and DW. Okay, let's take JW and DW to a fresher space in the paper so that we can go through this. So we got DW here and we got JW here. Now, what is D and what is J? If you recall the supply function, D and J are simply parameters that tell you the magnitude of change whenever there is an increase in the wages and how this affects the cost of production. Okay, now let's take a look at technological progression. So tech progression here simply means that the cost of production has fallen, right? It's just a fancy name for that. Okay, and maybe the cost of production would have fallen because these firms become better at producing these things, so they have lesser wastage, they become more efficient. Okay, so maybe the need for labor has decreased, or maybe they use labor in a more efficient manner. Okay, so that is tech progression. So when this happens, the parameters D would fall and the parameters J would fall. Okay, so let's go back to the general equilibrium graph, and let's assume that the parameter d has fallen. So when d falls, what this means is that you are going to have a vertical intercept for EDX equals to 0 that is less negative. So the EDX equals to 0 curve is going to shift up to the red one that you see over here. So this is the new general equilibrium point, and the price of x is going to fall, and then the price of y is going to fall as well. So these are the two sets of prices that would make the entire economy be in general equilibrium. Okay, so this is how this dynamics of the EDX equals to 0 curves and the EDX equals to y curve, how they work together. So you see, when x and y are substitutes, what you can conclude is this: tech progression in one good would actually cause both of the prices to fall, so society is better off. So this is one of the conclusions that you can make from this entire analysis over here. Okay, so what if x and y, instead of substitutes, they are complements instead? So actually this is quite simple lah. Okay, it's really very simple. Just write down the demand function for good x. What you will notice is that now the parameter of E, instead of positive, now it is a negative. And then now you're going to write down the demand function for good y, and take a look at the parameter M. It used to be positive, now it is negative. Remember, the negative parameters here show that x and y are complements. So we now find our EDX equals to 0 curve. We don't have to do the whole math again, just write down what we had initially. Okay, so this is that linear equation, right? So what you do now is you just simply add a negative sign in front of E, and what you'll notice is that you have a negative slope for the EDX equals to 0 curve, and you have a positive vertical intercept for the EDX equals to 0 curve. Alright, now let's put this onto the graph first. Okay, we'll go to the EDY equals to 0 curve later. Let's just plot this out so that we can see what it looks like. Okay, so positive vertical intercept somewhere here, okay? And negative slope means it is downward sloping. So this is the EDX equals to 0 curve. Simple. Now we move on to the EDY equals to 0 curve. We simply write down the old equation that we got for the EDY equals to 0 equilibrium. So it was this one, right? If you recall. And what we do now is simply add a negative sign in front of the parameter M. Oh, it seems like there is only one. Okay, so what you notice here is that it also has a negative slope, and it also has a vertical intercept that is positive. So EDY equals to 0 could start here, or it could start here. Let's just say that it starts here. So I draw a curve with a negative slope, and there I have it. This is the general equilibrium point for good x and good y when they are complements. Okay, so px star and py star will give me the general equilibrium. Okay, so that's pretty awesome, right? It is awesome because it is really simple to understand. A lot of students shy away from horizontal general equilibrium, but it's not that tough. Okay, I think it's because in the textbooks and in the guides there's just so much text in it that is scary to read, right? But hopefully this video has given you, a very good idea of what horizontal general equilibrium is. Okay, now I want you to ask yourself. Okay, we've seen this in the case whereby x and y are substitutes. I want you to try and ask yourself, what would happen if there was technological progression in good x when x and y are complements? Use the way that I came up with the conclusion previously, okay? Alright, so we've come to the end of this video on horizontal general equilibrium. It was quite fun teaching you guys this thing, and I want to thank you for studying with Quickienomics.